All right. Advent code day 7. So map kind of started to come together. So over here we clearly have a Christmas tree. This looks like it's supposed to be like a pond or something. Maybe there's going to be like a river here. It's an oasis in a desert, maybe. Trying to remember if there was. Yeah, I don't remember anything about there being like a desert there. Um, so for like last year, I loved the map last year. If you haven't seen it, it's really cool. Here it is. So the metaphor was there were these five floating islands, and so like you went up like this was the snow island. This was like a water slash lake island. Then there was a desert island. Then like the machinery island. Then a lava island, and back down. It's really cool. Um, I haven't done all the others yet. I haven't finished any of them, but like 2015 was kind of the start where you had a Christmas tree, and then like here we have a city going on. I haven't worked on all of these. Like it's like a oh, that's cool. I didn't see the animation. So anyway, I think there's a lot of like nice little effort put in here. Like this one, it's searching through a jungle is the metaphor, but I haven't gotten very far in it yet. But yeah, I don't know. I'm excited to kind of see what fills out here as we go. So here is my day 6 main. And then let me get my day 6 resources up. Input test. Okay. 27 seconds. And once that is active, we'll go. 2, 1. All right. And we are in there. So I'll move it over here for now so it's on the screen, then I'll slide it. Okay. Story stuff. You have to be careful about time paradoxes. Okay. In the year 1518, so avoid anyone from 1518 while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the land. Maybe you can work out where the guard will go ahead of time. Okay, so here is the map. The map shows the current position of the guard facing up. Okay, so we have a grid. Our test input. Um, we have some kind of boulder tree obstruction. Okay, any obstructions are shown as pound. Lab guards in 1518 follow a very strict protocol. If there's something directly in front of you, turn right 90 degrees. Otherwise, take a step forward. Okay, so right, because there's now an obstacle, turns right before continuing straight, new direction, reaching another, blah blah blah. Okay. Okay. Eventually, by predicting guards route, you can determine which specific. Okay, so the guard does eventually leave. Okay, so first we need to get the map. So we have our lines, and we want to turn this into another grid bar, and this is going to be equals lines dot or sorry, grid lines dot map it dot to car array. dot to mutable list dot to mutable list. And that's lines. All right. So I have my grid. And then from there, I'm just going to have a fun is obstruction grid or a coordinate grid coordinate. And that's just going to equal okay, equal grid dot equal grid get coordinate equals pound. And why does it not like this? Oh, right. Okay. So I'm going to pass the grid to part one results, and then add parameter function, get part one. Yep. And then it's just going to be, okay, so we have oh yeah, I also need to do val guard start grid coordinate equals grid dot coordinates dot single grid dot get coordinate, or actually let me do it this way. Yeah, grid dot, I'll just do it this way. Grid dot get it equals caret. Now, is it always a starting point of a caret? Okay, let me check my real input, because my bet is that okay, it is up on my real input as well. How big is my real input? Okay, it's not that big. All right. So, and then we want to pass in guard start. All right. So now it's just going to be let's do val path equals, do I need a list or do I need a set? Let me look at the directions. Do I need order or do I need a set? Okay, I just need a set. The path equals set of grid coordinates okay, and then I'm just making sure that the starting point does count on the path. So path dot add guard start val guard position equals guard start, and then while grid dot is in bounds guard position, we're going to do, so the guard's going to step forward. Oh, val guard direction equals and I just based on the input, I'm just going to say cardinal direction dot up. Okay. Then forward, val forward equals guard position dot get movement in the cardinal direction of guard direction. If is obstruction, or actually let's do it this way, while is obstruction forward, um, is how I think of it, even though technically I think with the input it gives, well, no, there are corners. So do they explain corners here? There's no corner cases, but I'm going to assume that if there's an obstruction in front of you, you're just going to turn right until there's not an obstruction in front of you. So while is obstruction forward, we want to turn right. Guard direction equals guard direction dot. Do I have any kind of like clockwise on this? Val clockwise. Up clockwise becomes right. Right becomes down. Down becomes left. Left becomes up. Okay. Dot clockwise. Oh, then that means, yeah, this needs to be a var, and actually guard position needs to be a var anyway. Okay, so now at this, oh, and then I need to update forward. Forward equals that. All right, so that handles turning the guard, and then from there, now I know that I can step forward, so it's just going to be path.add forward, guard position equals forward. And I'm going to just keep doing that until I'm out of bounds, and then return path.size is what I understand it being. 41 distinct spots. Okay, so let's see if this works for the test input. Just here. Okay, I crashed. I crashed because index out of bounds. Right. Okay, I know what's actually going on here. It is that I need to update the. I know exactly what I'm doing wrong. It is when on my is obstruction. I'm going to need to update this a bit. It's going to be grid dot is in bounds coordinate and. Okay, so now what's going on here? Print line path. Okay. We're going 6-4, 5-4, 3-4. 1-4, 1-4. Um, First, let me just check. Upright, facing right goes down. Facing down, I go to left. If I'm facing left, I go up. That part I think is right. So then let me just do um print line. Let's just see where I'm. File is obstruction. Okay. So this is never true? Wait, I'm taking 2 steps forward somehow. This returns a new coordinate, right? Yeah, it returns a new coordinate. Okay. Oh, I see. I see. I see what I'm doing wrong. 41. Okay, hang on. How am I getting 41? Because right. I'm counting stepping out of bounds. Right. Okay. Yes, that makes sense now. Okay, there we go. Part 1 in the books. Part 2. Okay, you borrow your fancy device from outside. From the safety of the supply closet, you time travel through the last few months and record the nightly status of the guards posted on the wall of the closet. Returning after it seems like a few seconds to the historians, they explain that the guards' patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, I'm pretty sure that adding a single new obstruction won't cause a time paradox. They'd like to place the new obstruction in such a way that the guard will get stuck in a loop, making the rest lab safe to search. Okay, this is going to suck. Um, have the lowest chance of creating time paradox would like to know all possible positions for such an obstruction. Can be placed at the starting position. This is gonna suck. Okay, so actually though, I have an idea. Okay, I think it's actually that no, I can't use rectangles here. I don't think. I don't think I can do anything as simple as just using a rectangle. Can I? Okay, hang on. Right, this is a rectangle, and if we put it there, we get stuck in this rectangle. And if we put it here, we get stuck in this rectangle. We put it there, we get stuck in this rectangle. No, but here the loop is quite a bit more complicated. Yeah. Option 6, put a tang. Okay. How many different positions? Okay. So I need a way to detect if I've entered a loop. fun is loop. Coordinates, it's going to be guard start grid. And that's going to be new obstacle, new obstruction at grid coordinate. I'm just going to try a brute force approach first because I can't think of any other way to do this. But what I'm going to do is I don't need to check every single cell. I only need to check cells that are along the path because the point is I'm putting an obstruction where I would otherwise travel. So I can slightly reduce. I mean, you know, the grid size that of my input is what? How long is a line? Let's see. Character count. So it's 130 by 130, and that's yeah. So I'm reducing my search space by about 3/4 if I only look on the path. But then the trick is that I need to see, okay, do I enter an infinite loop? And it's not as simple as checking, have I visited a previous point? It is like, it's going to look the same as traveling the path, but very specifically, so it's going to start looking the same, but there's going to be a little trick. This is going to be, if I reach this far, it's actually going to be returned false. And it's because, while I know there's a lot of duplicate code here and it's not super clean, I'm going to not just include the path, I'm going to include val path direction, which is going to be a mutable set of pair, and it's going to be grid coordinate and the direction that I was on. And you might think it's redundant to do this with two separate maps, but the point is I still want very fast lookup of just the path. I want to be able to very quickly add things to the path. Check if they're there and then add them, but I also want to very quickly do this, and they just hash to two different things. I could do a hash map with a list direction, but to me it just makes it more sensical to just do this, even though it ends up being a bit redundant. Which is going to now do pair, and that's going to be guard start direction dot, oh shit, it's cardinal direction dot up. Sorry, it's cardinal direction, so I've now imported something that I don't actually want to import. All right. So now I have cardinal direction dot up, and what I'm going to do is I'm going to step through the same way, but specifically what I'm going to check is, okay, so if the guard starts from this position and we step forward, we step forward, we step forward, and I can do some optimizations here to like initialize these, to pass in these values and initialize them. But we need some way of now checking, have we entered the same point facing the same direction? Because the key is it's finite state system, and if we enter the same point and we're facing the same direction, then we know we're now in a loop. That's how we check if we're in a loop. So we're going to do if path directions dot contains, and it's going to be the point forward, so pair forward and guard direction, return false. No, return true, because we are in a loop. And then path directions.add, just to reduce the val new position direction equals pair. I'll just call this new pair. And if it contains that pair, do that. Otherwise, we add the pair. There we go. Okay. Otherwise, eventually we'll exit. Um, and if we exit, we know that we're not coming back. Okay. So now this is going to be ugly because I'm sort of doing this twice, but specifically, what I'm going to be doing different is instead of actually checking this path and everything, I don't actually really care. Um, no, I do care. I do care. Um, let's actually just do it. Let's do the brute force way where I check everything, and because I'm just realizing now with the path, with if I only put obstructions in the path, I'm gonna have to like handle logic of is this the first time I visit a point or is it the second time? And I just realized like with that extra logic, it's actually might because I don't have to do logic if I just brute force every combination, it might actually be faster that way, which is just grid dot get or grid dot coordinates dot filter or a count, and it's um oh no, did I just delete the wrong stuff? Right. Okay, I did. So it's going to be grid dot count grid dot coordinates dot count, and it's coordinate arrow is loop. Actually, no, because I also want to filter out the filter not is obstruction. Then is then dot count is loop it guard start grid new obstruction, which is going to be that's the it value, and then I return that. Okay, check this on my test input. Oh, let me take out this print statement. Oh, wait, what? Hang on. Okay, path directions is increasing. But I'm getting 0, which means it's saying this is never true. Which just doesn't make sense to me that that's happening. Oh, right. Because um, checking is obstruction or and it's forward equals new obstruction. There we go. Okay, that's yep. I'm actually pretty happy with this. If this works. Oh, is it doing the thing? It's doing the thing, isn't it? Okay, no, it didn't. Okay, let's try it. I'm pretty happy with how fast I got that. 28 minutes. I mean, I know I didn't make top leaderboard. I want to be 100% clear. Know for a fact I didn't do that. But, I mean, like, top times are like sub 9. Okay, fine. They're also probably not talking aloud their thought process. And also, I don't have any aspirations of ever realistically making the leaderboard. I'm just going to be completely honest. But, hey, I mean, let me check my personal times here. Rank 2000. All right, rank 1427. I'm happy with that. I'm happy with rank 1420. I'm like these are two good rankings for me. You know, I'll take that. I mean, I've only done better than that once on the part one, and this is the best part two I've had. Oh, let's see, private leaderboard. Let's check the Kotlin one. Ah, nice. Look at that. Fourth fastest on this leaderboard, potentially, or at least top four. I technically can't look at the individual times. Let's check my personal private leaderboard. No one else up because they have lives. Okay, let's explain some code here. And yes, I know this code is fuck ugly. Like, I totally get that this code is fuck ugly. But at least this particular code is fuck ugly. This is fine. This is like just I can't imagine another way to really write this that looks cleaner. The point is, like we're getting our guard position, we're getting the grid. That part is straightforward, just grid parsing. Again, I have this built-in grid class that I used, and now I have. And you know what? Since I'm here, I might as well do val counter just while I'm here. And this is going to be now left, and this is going to be right becomes up, and this is now going to be right. Like I dollars to donuts, I'll have to use this. And this becomes down. Okay, so this is just a way to handle rotation. My directions all have these little vectors: -1, 0 for up, 0, -1 for left, 1, 0 for down, 0, 1 for right. Uh, and I hard coded that the guard start direction was up because it was up in both my test input and in my and in the actual input I got. If they had like a V, that would probably be down, and the carrots. Same idea. He's used this type of arrow before. Um, but yeah, I mean, I just need to track my path as a set, and it's mutable set of is hash set. So I want very fast lookup speeds here. I don't want to have to be doing some kind of n squared looking through a list. So fast, fast, fast. Use a set. We need to add the guard starting position to the set, and then there's the guard position up, and then from there, this part is just keep moving forward and doing the right turn to avoid obstructions until you're out of bounds. So once we're out of bounds, that's the end of the path. Um, and then you just get the forward position. This get movement, it's just if I go to the grid coordinate class, you know, this is just, hey, take your current position and then add d row d column to it. That's it. Um, so this is like if I'm facing right, forward is right. If I'm facing left, forward's left. Like I've written this stuff myself because there's a lot of this sort of like, you know, move in a direction type thing. So I get hey, get movement in the guard's current facing direction. If forward is an obstruction, then we keep turning clockwise until keep turning clockwise and update forward until forward is no longer an obstruction. From there, we then do now the point being after this loop, we know forward is an empty space that the guard can move to, and the guard is facing in that direction because I updated the guard's direction of facing. So then we add the path to forward and we move the guard forward. We add forward to the path and we move the guard forward. At the end, we do path size -1, not path size for the length of the path, because the guard on the last step did move out of bounds, and that out of bounds is not considered part of the path. Okay. Okay. And then this is where with this is obstruction, I had to have grid is in bounds coordinate because something can only be an obstruction if it is in bounds. If it's out of bounds, it's not obstruction. And this just helps us, basically sort of, well, I mean, it avoids an index out of bounds exception, obviously. That's the big thing. But yeah. From there, grid part 2. Let's take a look at is loop. And admittedly, this is a brute force solution. I'm not doing any kind of like clever geometry or anything. I am just brute forcing like for the guard start position, for the grid, and for a new obstruction. We're basically just going to do the same. Like most of this logic is the same logic that we do up here. Travel the path. The key, however, is that we're going to keep track of, for loop detection, we're going to keep track of this path directions. And it's just a tuple of a coordinate and the direction you were facing when you're on that coordinate. I can't detect the loop by if I visit the same coordinate twice because it's possible that like I go up and visit a coordinate and then I visit again when I'm like going left because I've looped around. And that's not a loop necessarily because I could go like up, over, and then left and all the way out of bounds. Like that terminates, so it's not a loop. So specifically to check a loop, I'm checking have I been at that coordinate, or has the guard, I should say, been at that coordinate uh, and facing the same direction. Because if I've been at that coordinate and been at that coordinate where I'm now facing the same direction, then I know I'm in a loop. That's the trick. But I still want fast look up for path time. Um, do I do anything with path here actually in hindsight? Actually, let's real quick. If I delete path, okay, I actually don't think I need the path at all. Yeah, I think I just need the path directions. Okay, yeah, I just need the path directions in hindsight. Okay, so this is the path, but I'm keeping track of the coordinates, and the point is, otherwise movement logic is the same. Get the forward position. While it's an obstruction, move clockwise. But the key is it's either in the obstruction set or it equals new obstruction. And in hindsight, I should actually reverse these. Um, I should change the order of these for like a super, super, super micro optimization. I'm just going to change the order of these quick. Because technically this is a faster lookup. Uh, so if it's the new obstruction or it is an existing obstruction, then we do the turn right thing. Um, you know, I realized there could actually be there could be a trap here. The trap could be if the guard starts in like a dead end. So there's boxes on 3 sides. I could end up with an infinite loop where it's 4 sides. And the way I would fix that is actually I would basically be adding the path directions here for the guard facing here, except I could run into a problem with that. That is nasty. I'll worry about that another time. Um, well, not another time. I'm never going to come back to this. But anyway, so now add the path direction, and then update the guard position, same as before. But specifically, if we have been at that coordinate facing the same direction before, we are now in a loop. Return true. Done. Um, and then from there, it's just a matter of this is just the brute force side of it. Get all of the coordinates in the grid that aren't already an obstruction, and then just test, hey, if we put an obstruction at that coordinate, is it a loop? And that's it. That's the code. So yeah, I mean, yeah, there's a little bit of duplicate code here, but I'm okay with it because it doesn't really benefit me in any way to add this logic in because here, like very specifically, I'm trying to get a boolean. Here, very specifically, I'm trying to get a thing like I could probably dry this out somehow, but I don't care to. I think like to me it makes sense what I'm doing here. No, that's it. So let's do the commit and commit and push. And we're done. All right. Made up for yesterday. I actually thought I did pretty well today. I don't know. I'm happy with that. I'm happy with my leaderboard. I mean, when I'm not using like any generative AI or anything, like I'm happy with that leaderboard. Have a good night, all.